Hello everyone, welcome back to my educational channel Gyan Wizard. I am Ajmal. In this video we are going to learn about conical pendulum and we will calculate its time period. Conical pendulum is different from simple pendulum. In simple pendulum, the bob oscillates on an arc of a vertical circle like this one. But in case of a conical pendulum, the bob revolves in a horizontal circle. Here, the mass of the bob is m, length of the string is L, the fixed end of the string is O, and the O dash is the center of the horizontal radius. H is the height. When the bob revolves in a horizontal circle, it makes an angle theta with the vertical OO dash. In such a case, the system of mass m and the string is called the conical pendulum. Two forces acts on the mass of the bob. The first force is the gravitational force, which is vertically downward and its value is mg. And the second force is due to the tension in the string, which is towards the fixed end O. Here I have taken tension in the string as T dash because I will take T as the time period of the pendulum. This bob revolves in a horizontal circle. Therefore, the only force acting on this bob must be the horizontal force, and that acts toward the center. That means a centripetal force will act toward the center of this circle. That means there should be no vertical force acting on this bob. We will resolve the tension T dash in horizontal and vertical component. Resolving means finding the value in horizontal and the vertical directions. Here this angle is the theta, therefore this part, this along the opposite to the side will be equal to T dash sine theta, and this will be equal to T dash cos theta. In the same way we can resolve the L also. H is equal to L cos theta, and here AO dash is the radius, which will be equal to L sin theta. Since there should be no vertical force acting on this bob, that means the mg must be balanced by T dash cos theta. That means first we will get equation mg is equal to T dash cos theta. The value of T dash sin theta, this must be equal to the centripetal force. We have resolved T dash in horizontal and vertical components. Okay. Therefore, we will take here the tan theta, because tan theta will involve the opposite side of theta and the adjacent side. That means tan theta is equal to the T dash sin theta divided by T dash cos theta. Okay. Now T dash sin theta is equal to the centripetal force. Let V is the velocity of the pendulum, this bob, and R is the radius. Then centripetal force, then the centripetal force Fc will be equal to mv square divided by R. And its velocity v will be equal to the distance covered in one revolution, that is the 2 pi r divided upon its time period t. So I can write down it as t dash sine theta is equal to the centripetal force, and centripetal force is m v square divided upon r, and t dash cos theta, my t dash cos theta, and this t dash cos theta, this is the in the upward direction and is balanced by the mg. This will be equal to m cancel out, this is equal to v chi square divided upon rg. Now we'll put the value of the v from here. This is equal to v square means 4 pi square r divided upon t square r into g. This r square. This r will cancel out this power. This is equal to tan theta. We have to find the value of t. T square, that means t will be equal to square root of, when we will take, okay, let me find out first t square. This is equal to 4 pi square r divided upon g into tan theta. This is equal to, or t is equal to, let me rub it. T is equal to 2 pi root of r divided upon g into tan theta. Value of r, we can put r is equal to L sine theta. L sine theta. Tan theta we can write down sine theta divided upon cos theta. Sine theta will be cancelled out and cos theta will go in numerator. This is equal to 2 pi root of L cos theta divided upon g. L cos theta is equal to the h. So this is the formula for time period of the conical pendulum. Here the important thing is the time period is independent of the mass of the bob. It only depends on the value of the h and the acceleration due to gravity at that particular point. Hope you find this video useful and informative. Please like it and subscribe to my channel. Thank you very much for watching this video.